So I'll first give Alice a chance to welcome you to this first class, then we can proceed.
Eric, good morning.
Good morning.
Yeah, you said what?
Just that we can go ahead and begin. So I'll give you the chance to welcome officially to the class, and then we'll proceed. Yeah.
All right. So thank you guys for making up for this class. So this will be our first session. So you can just start by cross-checking whether you all managed to do the installation of Anaconda, because that's what you should be using. And so I can see we have Daniel Makali. How are you?
I'm good. How are you?
Yeah, I'm also fine. You've been well?
Yeah, I've been okay. Thanks.
Good. So you already have the Anaconda?
Yeah, I managed to install. I have it ready. Oh, I think so.
Cool. That's good.
Yeah.
Okay. So we have Emmeline. Emmeline, how are you? Emmeline Akinyi, you there? So I think she's on hold. I can check on Jacqueline. Jacqueline, how is the morning? Jacqueline, we can't hear you.
My morning is good.
So
everything is ready.
Sorry?
Hello, I'm saying I was able to to install the Anaconda. Yeah.
So you're good to go. You're welcome.
Thank you.
So it's the same JM. It's the same Jacqueline Miner. You're the same person.
Yeah, I'm using JM for audio.
All right. Well, no problem. Then we have Kevin. Kevin Kimani, how are you?
Hi, Alice. I'm fine, thank you. How are you?
I'm also very good, thank you. Yeah, so I saw your response. So you were able to download the Anaconda apart from the application.
Yeah, I've downloaded that. I couldn't run the other application because of location issues, but yeah,
So that one I can
Anaconda
check
is
with.
okay.
Okay. So if you have Anaconda, well and good, you're welcome.
All right, thank you.
Eric is the one with the other Eric, or it's another person?
Yeah, yes, that's me. That's me.
Okay, cool. So Emmeline, we've not heard from you. Emmeline, are you tuned? Yeah, and then you have Fiona. Fiona, how is the morning?
My morning is great. How about you guys? I hope everyone has had a good time from the last time we talked.
Yeah, sure. Okay, welcome. So Eric, I think that is it.
Oh, okay, thank you.
Probably, yeah, you're welcome.
So, I'll just ask for the students, you can just briefly introduce yourself, say what you do. Unfortunately, I couldn't make it on the orientation class. I had another meeting that evening. Then I'll also
sure.
give a brief introduction of myself. So we'll start with, so Daniel was the first one. So if you can just who you are, what you do, and your expectation of the course.
So, morning, guys, once again. I'm Daniel Makale. I'm a data processing executive at Dalberg Research. And what my expectation for the course is that I will be in a position to make it easy or try and ease the processes that we have at my workplace, and hopefully be a better data processing executive. Thanks.
Okay, thank you. Emmeline, do we have you yet? If not, Jacqueline?
Hi everyone, I'm Jacqueline. I'm yet to graduate. I'm still a student. My expectation for the course is that I'll be able to have the skill. I'm willing to add to. I have a background in computer science, so yet to finish, but data science is gonna be a good skill to add to my portfolio. So yeah, looking forward to learning.
Okay, thank you. Before I forgot, Daniel, do you have any background in computer science or programming?
No, I don't.
What's your background?
Statistics.
Okay.
Yeah.
Okay, thank you. Then Kelvin.
Hi, yeah, my name is Kelvin Kimani, and I do tech support for Lenovo company, and I studied business and IT. I have a little bit of background of programming and mathematics, but what I'm looking for is to get more in-depth understanding of data, so that just to use it to put myself to get an advantage in the current market, the job markets that we have there. Just to use it as an added skill.
Okay, thank you very much. Okay. Marlene, do we have you?
Hello.
Hello.
Yes, I think you now have me.
Yeah.
I had some problem with my microphone.
Okay.
I had to change the devices.
Okay, good. How are you doing this morning?
I'm well. Yes.
That's good. So I was just asking people to introduce themselves, what you do, and the expectations. Hello? Hello, Emmeline, can you hear me? I think she still has. Hello, can you hear? I think there are still audio issues, so we'll just get back to her. Let me just chat her.
Hello.
Hello, can you hear us?
Yes, now I can hear you.
Good. Yeah, so I was asking people to introduce themselves, what you do, your background, and your expectations of the course.
Right, morning once again. My name is Emmeline, and I work with the Kenya Students Christian Fellowship, some Christian NGO, and I work there as the finance and administration coordinator. So my reason for joining this is really just to add the skill. And as I had said some time back, that it's all about decision making. I need to improve on that. I think that was my key area, and maybe open up my career path in terms of adding something else to it. So
okay, thank you.
Yes,
thank you.
I don't have a background on data science, really. I think I had someone say that. So,
okay.
Yeah.
Okay, thank you. Had you managed to install Anaconda?
Yes, I did.
And it's working fine?
Yes.
Okay, thank you.
Yeah.
So thank you for those who are here. I think this is it for now. So Eric Gitonga is my name. Background in electrical engineering, worked in it for some time, left that, got into photography for some time, and now switching into data science, which I've been doing for the past year and a half or so. Was in cohort 5, which was in session last year in August. Then this year in March, I joined as a consultant training for predictive analytics. And so I've been doing this for them alongside Fiona and Alice. So we can go ahead and begin. So we'll just start with an introduction of Python. As you had been shown in the orientation meeting this past Tuesday, there are several modules in the course. We have the Python programming, and then after this, we go into NumPy, then Pandas. Then once you're done with those, we start visualization with Matplotlib, Seaborn, and Plotly. Then once done with that, we go into machine learning, where you go through the scikit-learn library. And from that, we do linear regression, logistic regression, k-means clustering, decision trees, and random forests. So that's the general lay of the land. For this specific module, Python programming, these are the things that we'll look at. So we'll give a very brief introduction to Python. Then we'll now go straight into the coding itself. And this is not supposed to be the equivalent of a computer science program where you get in-depth training on how to, on the theory of programming, on the theory of computers and things like that. This one will be giving you the foundational materials that will be necessary for you to do data science. Because since it's a Python-based program, the libraries are of course all Python-based. So we give you enough material to know how to conduct yourself around with Python code, how to set up code and things like that. So we're not going to go in depth, it'll just be more illustrational. We'll start on this with comments and variables, and then we look at data types, control structures, and then we'll finally end up with functions. So just a brief overview of what Python is like, the characteristics of Python. It's open source, meaning it's, well, the opposite of proprietary. Open source in the sense that it's available for you to use as freely as you want, also to modify it, to look at it. The source code is available, so you can go in it and examine it. And if there are any changes you want to make, you're free to do that. The licensing being that you now share whatever changes you have with the community. So you can be a developer, part of the developer team of the programming language. It's interpreted. This means that when you type the code, there's a special engine that looks at the code and executes the code on the fly. This is as opposed to a compiled language, something like C or Java, where you write the code and then it has to be translated by a separate software called a compiler into a language that the computer understands. And then the software is then, the program, whatever you've written, is then now executed on your machine. Python, well, it's the same thing. It still has to be translated into a language the computer understands, but instead of going through that compile phase, there's a special engine that just allows it to be immediately executed without having to go through the compile phase. It's multi-purpose. You can use it for a whole host of different things. In this case, we're using it for data science to come up with whatever analysis and manipulation of data that we are going to explore. You can use it for general purpose programming, meaning just developing software that you use for general purpose things like games or the music software or things like that. And so this is in opposition to maybe a language like R, which is another language that you use for data science. R is heavily influenced by the statistics field. A lot of statisticians use R. And you are able to do some things with R, but not with as much flexibility as Python. Python is able to do a lot more stuff than R. Python, you can also come up with a code that generates websites for you. So once you've done your data science, there are libraries you can use now to put that on a website, and that so that then it's visible to the end users. So for example, if you have an algorithm that reads in data, comes up with a machine learning model for your company, then you can use Python to create a website where people in the company can now interact with whatever model you've come up with. It's cross-platform, meaning you can use it across different types of machines, different types of operating systems. Right now we're on Windows. I also run Linux on my machine, so I use it on there. Even people with Macs, even on embedded systems, you can create applications from Python for that. It's dynamically typed, and this one you'll understand better when we go into the actual coding itself. By dynamically typed, it means that when you assign values to variables, something I'm going to explain a bit later, you don't have to specify what type that value is. The language automatically infers from whatever you have assigned what type it is. This is opposed to a statically typed language like C, where every time you are assigning a value to a variable, you have to explicitly state what type that variable is. And once you've defined the type, you can only assign values of that specific type to that variable. And if you want to change the type that variable is, then you have to redefine it with a new type. So for example, if it's a character, then you can only store characters in it. You cannot store numbers in it. If you want to store a number, then you have to redefine it and say that I'm now going to call this variable, but it's now going to be of a type number. Whereas for Python, you don't have to do that. I can have a variable var, and one time I can say var is assigned to my name, Eric. And every time I call var, Eric comes up. And then I might decide later on, no, I don't want it to be that. Let it be a number. So the next time I can just assign var is equals to 10. So anytime I call it after that, I get back the number 10. So that's what we mean by dynamically typed. Then it's indentation aware. This means that code blocks in the software are denoted by indentations from the left margin. And again, when we go into the coding itself, you'll see what this means. This is contrasted with other languages that might use different things to show code blocks. Some might use parentheses, some might use semicolons and things like that. But for Python, you only indent from the left margin to show that this is a code block that goes together. We'll start off with the core Python, which is what this week and next week is going to look at. Then once we are done with that, we shall go into Python libraries. And libraries are specialized code that has been put together to perform specific tasks. Everything libraries can do, you can do with the vanilla Python, with the core Python. The only thing is that the libraries usually are written and they usually encapsulate series of steps that you'll perform in several lines of code into fewer lines of code and do it more efficiently than you would with those several lines of code. So we have these ones listed here: NumPy, Pandas, Matplotlib, Seaborn, scikit-learn, and these perform different functions. NumPy is mostly a numeric, it actually stands for numerical Python, and it's used for a lot of mathematical operations. Then we have Pandas, which is used for tabular data. And this is now the workhorse of data science. So when we do a lot of the analysis, reading in the data, manipulating it, cleaning it up and everything, that's going to be mainly in Pandas. Then we'll go into the visualization libraries, Matplotlib and Seaborn. These help us visualize the data graphically. It's much easier to communicate information to people from graphics than just from rows and columns of numbers. When you give them a graph that represents something based on the data, it's easier for them to see what's going on. So these two are libraries that help us do that. And then scikit-learn is a machine learning library. A lot of the different algorithms used in machine learning are under this scikit-learn library. So the logistics regression, the linear regression, the k-means clustering, those are different modules within the scikit-learn library. And that's the very brief introduction I have on the language. I'm going to share a link that will give you information, more information on the language should you be interested. I'll share a link to the Python website itself, which has got a very extensive set of documentation. And if you want to explore further more about it and everything, then you can go through that. But for these purposes, I'm going to just stop on there. Any questions so far? If not, we shall proceed. So let's go ahead and start Anaconda. So once you've started it, just indicate in chat so that we can proceed. Started it and gotten to a screen similar to this. You will, depending on the setup of your machine, you're not going to see the same exact thing. You might probably see just the root directory on your machine, the desktop, download, all those folders. But once you have something that's similar to this, please indicate in chat so that we can proceed.
So Eric,
Yes.
this is Jupyter Notebook, and they've probably opened Anaconda Navigator. So tell them to launch Jupyter Notebook, otherwise they won't get here.
Okay, okay. Thank you. Some of us have not done this for so long that we just assume immediately. So let me start from the beginning.
Yeah, just open Anaconda Navigator and then guide them from
there. Okay. My Anaconda Navigator has even disappeared. I hid it far away. It's here. Okay. Let mine open up. Okay, I see Jacqueline and Kelvin have done it. Emmeline and Daniel. So let me just start. Share with Anaconda. So when you open Anaconda Navigator, this is the screen that comes up. What you want to do is just launch Jupyter Notebook. So you'll just go ahead and click on launch. This is one way of starting Jupyter Notebook. You can open Anaconda Navigator and then launch Jupyter Notebook. The way I do it is from, a second. No, it's not on my machine for now, but for now, we can go ahead and just, once you've launched Anaconda Navigator, just click on the launch for Jupyter Notebooks, just click on launch, and that should bring up the Jupyter Notebook.
So just to mention, the Jupyter Notebook will be opened on your default browser. So look for it either on Chrome, Firefox, or whatever your default browser is.
Yes, yes. So you'll open it and just open, as Fiona has said, it'll open in the browser. And like you see, oh, I need to reshare my screen because you will not see it once it's opened up. Stop share. Share. Where do I have you? So it opens up in your browser and you should get something that looks like this. Okay, Daniel, yours is taking a while. Emmeline, have you been able to open yours
Yes, I have.
and gotten to this screen?
Yes.
Okay, good. So let's just wait for Daniel. Go ahead and just explore the different aspects of Jupyter Notebook. So like I had said, when it opens up, you come to a screen that looks like this. Yours is going to list different things. When it opens up as default, I've set mine to open up at a specific location. That's why you don't see the things that you're probably seeing on yours. But you should still be able to see the different folders that are on your machine, depending on where it opened up. What I would advise you to do and would make your work much easier is that if you go to click on the desktop folder. So if actually, let me just create a desktop folder on here. Give me a second. I can actually explain what I'm doing as I'm going ahead. If you want to create a new folder, on the top right, there's this button new. Click on that and then click on folder. And that is going to bring up a folder called untitled folder as part of your list. To rename it, click on the checkbox to the left of that. And then at the top, there's the rename button. Click on that and you can rename it to whatever you want. So in this case, I'm renaming mine desktop. When you open up yours, you'll have a desktop appearing on it. So I just want to make something that will make your life easier. Since your desktop is already there, just click on desktop. Then once in desktop, create a new folder. And I want you to rename that folder data science, so that all the material that we use, any material we share with you, any files that we share with you, we want you to put it in this one, in subfolders within this data science folder. So again, we'll have, for each of them, we'll have a different folder. So this first one, we can just call it Python. So any materials we'll do will be in the Python folder. This makes it easier. Usually we've seen that it's a problem when we share files and material, students find it hard where to locate them, where to open them and everything. And this will also become, the importance of having the files in one folder will become apparent once we now go into something like Pandas, where we start accessing files for whatever work we are doing. For today's class, it's not as paramount, but it's just good to start developing that discipline from now, that each class has its files in that specific folder. So at the end of it all, you should be in your Python folder. So go into desktop, create a folder, data science, create a folder Python, and then go into that, the directory itself. Please say so once you've been able to do that. Then Daniel, update on your progress.
Excuse me.
Yes.
Kindly take me back through that once I'm at the desktop. I
Are
clicked
you,
on,
so
yeah.
are you at desktop now?
Yes, like I ticked on that. I checked the
Okay.
box. Yes.
Did you open the desktop folder itself? So to go to desktop, just click on it.
Right.
Not check, just click on it.
Oh, all right.
Yeah.
Yes.
Then now, once there, just a moment. Daniel, you could probably just chat Fiona. She should be able to assist you. So just chat privately with Fiona. She should be able to assist you and help you with your problem. So once in the desktop folder, click on the new button on the top right,
Yes.
and then select folder.
Yes.
Then to change the name, click on the checkbox next to it,
Yes.
and then rename, the rename button. And then now you can rename it.
Oh, okay.
Okay.
Yeah.
So you'll rename that data science, you'll go into that and then repeat the steps, create a folder Python, and then go into Python. Understood?
Yes. Thank you.
Okay. So once everybody has done that and are in the Python folder, please indicate on chat. Okay, thank you, Kelvin. Jacqueline done. Okay, Emmeline, let me know when you're done. You. Emmeline, are you able to share your screen so that I can help guide you on what to do? Okay, I've seen you using two different gadgets. So where are you still unable to rename?
Yes. So I'm actually at the untitled folder
Uh-huh.
after the data science. So for me to rename it to have it as Python.
Mm-hmm.
Yeah,
So
that is where I am at.
you click on the checkbox next to that.
All right.
So actually, let me just do a new
Okay.
folder.
Okay. Okay.
Yeah, so click on the checkbox and that brings up the rename button at the top.
All right. Now I'm good.
Okay, so yeah, do that and then now go into the Python folder. Okay. So now that we are all here, this is what all your screens should look like. The notebook is empty, the notebook list is empty. Desktop, data science, Python. On here, we have the different sections. So this is just the the root directory, from the root directory to the current directory, which in this case is Python. The only things that I'm going to show here is, so there's the new button. We've looked at the folder already. You can also come up with a text file and type stuff in it. You can also come up with terminal. For now, these two, we are not going to use them, but just to show you that they are there. The one we use is Python 3. That's what we are going to come up with. But before we do that, up here, there's the files, then there's the running. Running shows you the different windows that you have, whether it is terminals or the notebooks. And then we are not going to have much need of that, or even for clusters for now. Files is where we are going to do majority of the things. Then we also have the upload button. And if you have certain files that, like now, for example, the files that I'm saying will be sending to you, once you've downloaded them onto your machine, you'll click on the upload button. Then you'll just go to wherever they are. In this case, let me do what? Downloads, Introduction to Python Programming, and then upload. And then it's now going to bring it to the current working directory. This will be the most efficient way of making sure that you have the necessary files you need in the working directory. So once again, you click on upload, navigate to your downloads folder, click whatever file you want. If you have several files, you can click on them and then click on open, and then just upload each of them. And now you have the files in your working directory. So in future, anytime we share files and we say download and put them in the working directory, those are the steps that you're going to follow to do that. You can, if you have files you don't need in the working directory, you can just select them and then just click on the delete button. And that's going to delete the files from your working directory. So that's it from this portion. Anybody with a question on this? Okay, so let's go ahead and now create a new Python notebook. So click on new and then select Python. You should read Python 3 because Anaconda installs with Python version 3 and up. So you shouldn't read anything other than Python 3. So go ahead and click that. And it will open a new tab. And the new tab is now going to have the empty notebook in place. So again, here I'll just give a very brief overview of the different parts of the notebook. I'll touch on the ones that we'll use on the most and just lightly brush over whatever we don't usually use. Start with the file menu. So on file, it enables you to also open a new notebook or open an existing notebook. You can make a copy of the notebook itself. And when you do that, like for example, actually even before I go to file, let me start from the very, what I should have started with first. At the very top, you have this Jupyter, and then to its right, the untitled. This is the name of your notebook. If you click on that, it should bring up this window that enables you to rename it. So here you can rename this to Python. So that's how you rename your notebook. And once you do this, if you go back to the file listing, you'll see that it has changed from untitled to Python. If I name it into something else, first class, and then I go back, same thing. Oh, sorry. Give me a second. Yeah, same thing. It's now changed from Python to first class. So let me just change it back to Python. So that's how you rename your notebook. So on the file, you can make a copy. And if you do that, it automatically generates the copy. And then now it just appends a hyphen copy and the number of copy to the file name. So now if I go back to my listing, I see that I now have Python copy in place. Since I don't need that, first of all, let me come here and close this. So you can just close that specific window. Then you'll notice that this icon between the checkbox and the file name is green. That means that this particular file is running, and it's also indicated on the right that it's running. Should I want to stop it for whatever reason, you just click on the checkbox and click on shutdown. And you see it changes to black and the running is no longer in place. If I want, since I don't need it, I can go ahead and just delete that one. Okay. Then I think I want to close that window. Yeah, so let me now go back to my notebook. That's how you make a copy of a notebook. You can save it as something else, you can rename it here, or again from up here, as I'd mentioned. Save and checkpoint. What this does is that if you are working on your notebook, if you click on save and checkpoint, what it does is it saves a copy of your notebook at this time. So if I proceed with my work and then I get to a place and I realize that there's a mistake that I made, I can now go back and revert to a checkpoint. And you see it has shown here that there's a checkpoint that was created Saturday, October 10th, 2020 at 9:52 a.m. So I can go ahead and make changes and everything. So then what? Add a new cell, x equals sum. Then I find that I've made a mistake. Just click on go revert to checkpoint, Saturday, October 10, revert. And it takes me back to the last point where I'm sure that I had a properly functioning notebook. That's what that does. You can get your print preview and what it does. So let me do what print, Eric. What print preview does, it just shows you what it's going to look at. Sorry, that's not what I wanted. What it would look like should you want to print your notebook, and just bring this up, formatted for print. That's all that does. Go ahead and delete that. Then you can download your notebook in different file formats, depending on what you want to do, whether as an ASCII document, HTML, or any one of these others. The one that you'll probably use the most is as a notebook, but you don't have to do this because it's already in your working folder. Remember, once you've created the notebook, if you come to your working folder, it's in place here. So if somebody asks you for a copy of your notebook, you'll just access it from whatever folder you set it up in, from your working folder. If you still want to go ahead and download it as notebook, you can click on that and it's just going to generate it, and it'll click exact same file name, just as now it's going to appear in your downloads folder. As I've said, that's unnecessary because it's already in your working folder here. Go ahead and delete that. You can also, for now, I usually share the notebooks that we work through both as a notebook and as a PDF. It's a pain to set up Windows to do it as PDF. And so I never do it from this. And actually, I normally run my classes and everything from Linux. Today, I just did it from Windows so that I can walk you through the steps of getting into Anaconda Jupyter Notebook and everything. But from next week's class, I'll do my usual from Linux. The layout, everything is exactly the same, just that I'm using a different operating system. And I've set mine up such that I can download a PDF version of the notebook, which is good to reference offline. Well, not necessarily offline. It is good to reference without having to open Jupyter Notebook. A notebook, you can only open it in Jupyter Notebook or any platform that supports notebooks. So there's Jupyter Notebook, there's Google Colab. In fact, let me go there right now and show you what that looks like. As that's opening, I can open this as well. So yeah, Untitled. Okay, yes. So you see there's this, let me just remove that. You can open a notebook in Colab. You can open a notebook in Kaggle. Let's just look at an example of a notebook on here. Let me go to mine. Notebooks. So these again, same thing, you can open a notebook on here. So long as it has the extension IPYNB, which is IPython notebook. So you can open it either in Jupyter, in Colab, in Kaggle. There's also Jupyter, let me make sure. There's also Jupyter Lab, which is part of the Anaconda suite of software. You can do it there as well. For us, we're using Jupyter Notebook. Then the difference between Jupyter Notebook and these others is that for Colab and for Kaggle, you have to be connected to the internet for it to run. If you're not, then you won't be able to access the notebook. Jupyter Notebook is running natively on your machine, and so you don't have to be connected to the internet. It just, when you open it up, it just sets up a server locally on your machine and runs directly from that. So you can work from this offline. That's the advantage of using Jupyter Notebook or its equivalent Jupyter Lab. Those two, you don't have to be connected to the internet. Then, okay. Edit, here is just whatever edit operations you want. You can cut cells, copy cells, delete, you can merge cells, and all these you're going to see as we go along. So don't have to worry about them that much now. Whenever an operation from here is required, then at that point I'll explain it. Maybe the one I can do for now is probably cut cells. So print sum, then have a cell, maybe have a number here, and then have another cell. So maybe I want to move this from this top part to the bottom part, or maybe create a copy. So I can do edit, copy cell, and then I can come edit. I can either paste cell above, in which case it will paste it up there, or edit, paste cell below, in which case it's going to paste a new cell below there. Then you can cut cells and then come here and paste it at a different place. You can delete cell. Then if in case you've deleted a cell and you didn't mean to do that, so let me delete this one. You can just come and do undo delete cell, and it brings it back. So these edits are for cells themselves, not for the contents within the cell. For the contents within the cell, it's if I, for example, do accidentally delete that, then I can just do Control Z and bring back the text. But this has to be within the cell. These functions are cell-based functions. They're not for contents within the cells themselves. That's something different. Then there's view, this one. This one, I'm just going to look at the toggle tile numbers. Okay, there's toggle header, which toggles this specific line up here, the Jupyter Python notebook. There's toggle toolbar, which is going to toggle on and off these, the buttons down on there. Then there's toggle line numbers, which now toggles the numbers within the cells themselves. And this is good, for example, if you are trying to troubleshoot and somebody is trying to help you, you can say, I have a problem in cell X line 33. And that enables you to go to that specific cell, that specific line. That's what that is for. Cell toolbar, not important for now. Insert, you can insert cells above and below. Then for the specific, then now for cells, you can say run cells. This is just going to, whatever code you have in place, if you click on this, it's going to run the cells. So you can either run all of them, or you can run cells that are below the one that is selected, or run a cell. Let me start again. run cell, if I click on run cell, it's going to run that specific cell. It's going to execute the code in that specific cell. If I click on run cells and select below, it'll run that cell and then automatically advance to the next cell. And then finally, if I say run cell and insert below, let me do that when there's a cell with 2 bits of code in between them. So for example, on here, if I run cell and insert below, it will run that cell and select and add a new cell below that, a new empty cell below that. So those are the 3 different ways of doing it. For all these, there are keyboard shortcuts you can use, which you can use this for now, and also these buttons that I'll explain later, and I'll also explain some keyboard shortcuts which make life much easier. Then you can also do run all, in which case, if you click on run all, it's going to run all the cells in your notebook. Usually when we work with notebooks, and once we now even start going into some of the libraries where we are having a project in one notebook, you will want to, anytime you open the notebook, you want to do run all. Once you close your notebook, then it gets removed from your memory. Actually, not just close. Once you, let me go back to my, once you shut it down, it gets removed from your memory. So if you want to rerun it, if you open it again, then whatever variables and any definitions that were in that notebook are no longer in memory. For you to load them to memory, then you have to do run all. If I was to give a quick example, so use x equals 2, x, and then I get a new cell, run and insert, and then I call x. So I get back 2. So here, anytime I call on x, I'm going to get back 2. But if I was to go ahead and close this and then shut that down, then open. If I come down here and I run that, I get an error that x is not defined. That's because by shutting down my notebook, I removed it from memory. And so any definitions that had been placed in memory are no longer in place. To prevent this from happening, so let me go ahead and close this so that I can just demonstrate it, and then shut this down, then open it again. So if I come and do run all, now you see it runs everything from the top to the bottom. And so the next time I call x, the 2 is shown in place. Sometimes you, when we get to the stage, you will open your notebook, and maybe because we'll be working incrementally, you'll get to wherever we had stopped in the previous class, and you'll try running that code, and it'll bring up an error, the same error that had been displayed, that y is not defined, which means that whatever variables you are trying to call have not been defined previously. In most cases, the reason will be because you did not run all the cells. So it's usually advisable, once you open a notebook, run all the cells. Then there's run all above, which means that for the particular cell that's selected, run the cells, all the cells above that one to the beginning. So if I do run all above, it just runs everything from above until that specific cell. Run below is the opposite. All the cells from that point, all the cells after that point to the end. That's what those are for. Cell type, I'll explain that. Current outputs. These ones is just for toggling an output. So for example, if I have this cell here and I don't want to see the output, then I just toggle and I no longer see the output. If I click on that again, then I see the output. It's just, for example, you have a notebook that has code and you want to present it to somebody, and maybe you don't want them to see some of the output. So you can just come here and click toggle output, and it's the output for that specific cell is going to be hidden so that they themselves, when you export it, don't have to see it. What else? Then you can also clear the output. So for example, this one, if I don't want to see the output, or rather if I want it to get back to how it was before running the cell, then I have to do clear output. And it automatically clears that output and I no longer have it in place. So that's what that does. Kernel, this is the engine that's running this specific instance of the notebook. It's kind of like what is behind, what is powering the instance of the notebook. And there are different options on here. You can interrupt it, you can restart it, you can restart and clear, restart and run all, reconnect, shut down, change kernel to something else. The ones that you probably use the most here is interrupt. You might run into a situation where you have code that is infinite. Let me give a very brief example. While true print I. Oh, sorry, print one, I haven't defined I. So you see here I've created a loop that is an ending. It's going on and on and on, and there's no way to stop it. So if I just come and do kernel interrupt, then it stops that operation. So usually if you're running code and you find that you've done something that is going on indefinitely, that's when you use that button, interrupt. Then there's also restart, which means just sometimes you might run into a problem where the code looks okay, everything looks fine, but for some reason it's just not running the way it's supposed to be. Chances are probably something in memory has gotten messed up and you have to restart the kernel so that you can refresh everything in memory and reset it to a default value. So that's now when you do the restart. So if you click on restart, you don't see any change, but basically what it's done, it's gone into memory and it's just restocked everything. You can also restart and clear output, which in this case, you're definitely going to see a change. So if you do that, everything is now reset to 0. You don't see the outputs. Then you can also restart, you can restart and run all. Actually, before I do that, let me remove this because I don't want that infinite loop. So restart and run all. So it restarts the kernel and runs all the cells for you automatically. Sometimes it might shut down for whatever reason, so you'll just do reconnect. So let me shut it down myself, so shut down. And you see when you shut it down, up here you see no kernel, which means that it's not running. If I was now to try and run a cell, if I was to try and run this cell, it gets stuck on here. There's this asterisk which shows that the cell is running, but there's no output. That's because there's no kernel, there's nothing, the engine running the notebook has been shut down. And so it's unable to execute these commands. So then I need to come here and reconnect. Okay, connecting to kernel. Let me do interrupt first so that, okay, then reconnect. It's probably going to bring an issue because this specific cell, in this case, I've caused my kernel to hang. So I'll just have to close that down, leave, open up my notebook again. Let me delete that. Yeah, if it was shut down, you just click on reconnect and it reconnects it again. And the difference between one that's shut down and one that's not is that to the right of Python 3, there's this circle. Right now, you can see that it has a clear internal. But if I was to shut down my kernel, shut down, it now turns black, which is that my kernel is shut down. So let's go ahead and reconnect. Okay. This seems to be having, that specific function seems to be having a problem here. So I'll go ahead. That's what ideally it's supposed to do. I'll try and look at it and figure out why it's doing that. But for now, you can just move on from there. The rest, you don't have to worry too much about. Help, you can get help for whatever thing you want on here. The user interface, the different keyboard shortcuts. Remember, I'd mentioned some keyboard shortcuts and Also some of the different libraries. This will link you to the specific, it'll open a new window that leads you to the specific documentation of that. So for example, let me click on that one for now. And it automatically takes me to the documentation of that specific item. So this on the web itself, this is not running on my machine. Oh yeah, no, it's actually running on my machine. It opened, you see it opened, is it docs.scipy.org? Yeah, it's on the website itself. So it opens, it links to the website of that specific item you want to look at. If I want to go to the Python documentation, I click on that. It brings me to the Python documentation directly. So that's a very easy way of getting information about the core Python and some of the different libraries. Pandas reference, something that you're going to use. It takes you to the Pandas documentation. So that's the help for you. So that's the menu bar. Any questions so far? Okay, good. Then now there are these icons on here. There is the save button, same thing as the save as. You'll notice he's saying that the last checkpoint was 8 minutes ago, which was the last time I changed my file. So you can either click on that or you can do Control-S, keyboard shortcut, it'll do the same thing. The plus is for adding a new cell. A new cell has been added, as many as I want. The scissors are for cutting cells. So I've deleted those cells. Copy selected cell, and then paste cell below. So you can use that as well instead of coming to the menu. These arrows are for moving the cells up and down. So I can move my sum up, I can move it back down. This runs the cell and advances to the next cell. So run cell and it just moves to the next cell. This is for stopping. Let me get back my infinite loop. So while true, print 1. So we can see that I have my infinite loop on here. Clicking on this is going to stop the operation. This restart the kernel with dialog. We're not going to do that. I've realized that my kernel has an issue. This restarts the kernel, the whole book without dialog. No, this is going to restart the kernel and run all the cells. So let me first of all remove that infinite loop. So if I click on that, it'll bring this up. So restart and run all cells. So it restarts and runs the cells again. Then we have this code drop-down menu. And you see we have got code, markdown, raw NB convert, and heading. The ones that you'll focus on mostly is just code and markdown. NB convert is just to convert it to raw text. Heading is for having different types of headings in place, but we're not going, so these two we're not going to use at all. We'll be focused mainly on just code and markdown. The difference between these two is that code is any text in a cell that can be executed as code. So it defines that cell as a cell that has code to be executed. In this case, this first cell, we've got the print sum. If I run that, the code is executed. If I change this to markdown, then you see instantly there's some changes that have happened in the cell. There's this number to the right, it's disappeared. And then the colors that were on here have all changed to black. This is now just a regular text file. If I run this, it now changes from the gray background to this white background with just the words exactly as I've typed them out. And this is very good for documenting your code as you go along. You use markdown cells to explain what a specific cell is doing or what you're trying to do, or to give background about your project. And you'll appreciate this as we proceed on. In fact, the notebook that I'm going to show in Introduction to Python is going to have a lot of markdown cells that is explaining what's going on either in previous cells or in cells to come. That's what markdown is for. If you, for example, if you've set up, let's change a cell that has a number to markdown. So if I change that to markdown, and then I run this, and then I find I'm not getting any output, the chances are it's because it's been changed to Markdown. And if you come here, it's going to indicate that, yes, this changed to Markdown. That's why I'm not getting any reaction from trying to run this cell. So just come back here, change that to code, rerun it, and you get your output. So remember, code is for cells where you have code you want to execute. Markdown is for cells where you want to document what's going on. This will just give you some of the various keyboard shortcuts you can use for some of the different things. So again, I'm not going to go through it, but I encourage you to just look at it and see what is available. I'll just touch on a few keyboard shortcuts that I think will save you some bit of time. I've seen the question. Okay, what do you mean logging out?
At the top right there, you have the logout button.
Oh, this one. Good question. Actually, I've actually never used it. Let me see. Logout. Successfully log out. Return to login page. Password token 4. This one I think is for if you. I am going to have to explore this some more. I have never actually done that. So it's very good you've asked me that question. But I think it's for credentials. For example, if you're in a team and you're trying to and you're protecting the specific project, I'm guessing that's what it's for, such that this team, Kevin and I, are working on this specific project. And so we set up our credentials such that to access these notebooks, we have to put in our credentials in place. I'm guessing that's what it's for. But for most cases, you don't have to use that. Let me see if I come back here. Oh yeah, I have to do that. So it means then I'll have to exit Jupyter all the way completely and then restart my instance of Jupyter. So let me go ahead and do that.
Okay.
Open that. Okay. Delete that. Delete. Python, IPNB. Yeah, I've been able to get back in. Let me reshare my screen. Yeah, so it logged out of the instance that had been opened up when I launched Jupyter Notebook, and so my guess is that it's to help you. For example, when you're collaborating on teams, then you can provide credentials for specific projects to specific teams. That's what I think it is. But yeah, Fiona is finding out, so she will give us an answer once she finds that out. But thank you for that question.
Sure.
The beauty about teaching is that you always something new. This is actually the first time I've ever had to think about that. I've never thought about it. So we've gone through, oh yeah, I was talking about some keyboard shortcuts that you can use. Let me change this first cell to code. Actually, there's one I want to look at. Give me a second. Yeah, so some keyboard shortcuts. Changing from a code cell to Markdown, if you hit escape and then M, it changes to Markdown, and you can see the cell has changed immediately. If you're in a Markdown cell and you want to change it back to code, it is escape. Sorry. What have I done? Oh yeah, I muted myself accidentally. So if you want to change it back to code, it is escape and then Y. Shortcuts. For now, as you're starting out, you are very well, it's very well and good to just use the menu items and the buttons and everything. But as you go along, as you gain experience, you discover that keyboard shortcuts save a lot of time. So we've seen Markdown, escape M, code, escape Y. And then now for running the different cells, so there are these buttons. If you click on this button, it runs, advances to the next cell, or you can come to the cell menu, you can run that cell, you can run a cell and select the next one below, or you can run a cell and insert one below. Or you can use keyboard shortcuts. To run the current cell and remain in it, you do Control Enter. So Control Enter. You run the cell and you see each time I run the cell, the number to the left advances. I'll explain what these numbers are, but for now I'm just showing keyboard shortcuts. If you want to run the cell and advance to the next cell, it is Shift Enter. So each time I run, you see it's advancing to the next cell. Shift, enter. And if I'm at the bottom of the notebook and I press Shift, enter, it'll advance to the, it'll create a new cell if there was no cell after the last one. So every time I do Shift, enter, it creates runs the cell and creates a new cell. And then finally, if I want to run a cell and add a new empty cell after that, it is Alt, enter. So I've run the cell, it has added a new cell below that. If I come to this one, 10, Alt, enter, same thing. Run that cell, insert a new empty cell below that. Just some very handy keyboard shortcuts to use that in the long run, you'll find saves you much more time than just, like, for example, let me just add like tons of cells. So I'm all the way down at the bottom. And for example, if I've toggled header and I've toggled toolbar, and I don't have to now try and figure out, okay, where am I? I'm trying to run a cell and everything. I have to come back here, retoggle my toolbar, whatever. You can just use the keyboard shortcuts, print X. And then I can just use now the keyboard shortcuts. So print X, stay in that same cell, Shift X, run it and add a new cell, or Alt X and run and insert a new cell. You can use the keyboard arrows to navigate around your different cells. Let me see. Yeah, then there's also ways of navigating pages. Let me just see if I can do this. Change cell. For now, move cell, move cell. Scroll notebook up, so scroll notebook down, command space. So if I do space, I scroll, so command space scrolls down. So I escape for Windows, escape, then the space bar will scroll the whole notebook downwards. So let me go back all the way to the top, to this top cell. So if I want to scroll the entire notebook, it is escape, space bar. Then scrolling up is, let's see, scroll up, escape, shift, space bar. So escape, shift space bar, scrolls up. Just some handy shortcuts. You've noticed that I was referencing those ones because I've never really done the scrolling up and down. And so I came here to do this. Don't be afraid to refer to documentation. You're not going to like get an A grade for memorizing all the commands. And even something else, again, I want to emphasize now as we move forward is that all these things you are teaching you don't have to memorize them. You just need to know that I can do this, and this is the way of doing this. You might not know the specifics. You know that you can do this, but you don't know the specifics. The specifics, feel free to go to the documentation, feel free to go to Google, feel free to go to Stack Overflow. If a lot of data science stuff that you Google and try and get help for, chances are it will lead you to a Stack Overflow a solution. Let me do that just now. So Python, no, sorry, Jupyter Notebook scrolling around. Let me see if it's going to bring a Stack Overflow. Yes, you see, the first answer that has come is Stack Overflow. And a lot of the questions you're going to get that you have as we are going through the program, if you just Google, it's going to bring you to a Stack Overflow page, and somebody will have asked a question about it. And then you can just scroll down and try and see whether the answers that are given are going to answer your problem. So again, don't memorize, just understand the concepts. Just know that I can do this. And then for the specifics, seek out the documentation, search online and find out what's going on and everything. With time, the more you do it, the more you realize that a lot of even some of these things, you'll start to internalize them and you'll start to know them. And so the the memorizing is going to come as a result of long-term repeated use. Just as with language, if you're learning a language, if you don't practice it, if you don't speak it, if I want to learn German, if I read a textbook but I don't speak it, I'm not going to learn it. I might memorize the vocabulary and everything, but come to me a month from now and I'll be blank. But if you drop me in Berlin and leave me there for a month, even without a textbook, chances are that by the time you come back for me after a month, I'll have some working knowledge of German. And it's the same thing with this thing. We encourage you to practice, practice, practice. So whatever we teach you during the week, find avenues and ways to put that into practice. And over time, you'll find that a lot of these concepts start sticking. And even for something like some of the code that we take you through, you'll find that a lot of it, you now start to know it often, and you don't have to refer to documentation as much. There will still be instances where you don't use certain things as frequently as others. And for those ones, it's perfectly okay to go back to documentation and refresh and see what's going on. So that's something that I really want to emphasize for now. Okay, the last thing on Jupyter that I'm going to look at, now let's look at the cell itself. You'll notice that when I have the cell, when I have my cursor in place, you notice that this bar around it turns green. And then on the left, there's this the vertical bold green bar. This means that whatever code, whatever I'm doing in there is in edit mode. And so I can go ahead and add new code, print some, and maybe type some. All these things, I'll explain what they are. So it's green so long as I'm editing. But the moment I run it, it changes back to blue. And then I have my output. So when it's a blue bar, that's a code cell that has been successfully executed and run. I want to assume even one that has, yes, even one that has an error. If you run it, so long as the code cell has been executed, it's going to change from green to blue. Then what these numbers mean, so in stands for input. So basically this is where you're inputting your code, and then out stands for output. This is what is presented as an output from your code, if an output exists. In this case, on here, it exists. Because I've asked it to print sum and also to return the type of sum, and then when I run it, I get my output sum and I get the type of sum. So in is for the input code, out is for whatever output there is from that code. And the number in the brackets, the number in the square brackets is just a referential number. It says, it gives the number of the execution of that code. If I was to run this specific cell, you see now it's changed, this number has changed to 32. It doesn't have to be sequential. You see this is 31, then this is 22, then this is 32. This again is for reference. Like for example, if you're collaborating with somebody, or if you need help with something, then you can say in cell 32, I have this issue. And then say, for example, you have something that has several lines. So let's go ahead and assign sum to the variable X. Then here I print, instead of printing sum, I'm asking it to print X. Then cell, is this view, toggle line numbers. So here we have, in the event you're troubleshooting or collaborating with somebody, you can say in cell 33, line 2, I have this error. Please help. Actually, let me generate an error, print T. So in cell 34, line 2, I have an error. And you'll see in the output, there's an arrow pointing to the error. And it's showing that it is in line number 2. So it's good for reference. It's good for when you're trying to reference a specific cell in your code. And then with the additional line toggles, that also gives you an additional level of ability to reference specific lines of code. Good. Thank you. I've seen the answer that Fiona has brought us. Thank you for that. So that's what these numbers are. If you see, and then of course it's going to be different for different people, depending on how you've executed your code, depending on how often you've run your notebook. Each time I run, you see that different numbers are generated. If you want to refresh, if you want to reset it back to 1, then what you need to do is either kernel, restart and run all, or this double arrow button, which does the same thing. So let's just do from the menu bar, restart and run all, restart and run all. And then first of all, you'll notice that it just ran the first one and then the rest did not run. That's because when it executed the code, it turned into an error. And when it runs into an error, it stops execution until you fix that error. And so the rest, you'll see that the numbers next to them are empty. This is also something that gives you a clue that something is going wrong. So you see, it restarted ran all and automatically scrolled to the bottom. But you'll notice that at the bottom, let me see. Let me delete this line first, then do restart run all. Oh, sorry, continue running. So I restarted run all. I should no, this is not even going to work. Let me call that good. So restart run all. Okay, that ran, I don't know. Let me try and figure out what's going on. 10. Why is that one running and these others not running? Give me a second.
Might it be because the others are a print statement? The other is just calling,
but, you see,
but that also isn't running.
Exactly.
Okay.
So let me delete a whole bunch of cells and see. Okay, let me kernel restart run all. Okay, this time it's working. I'll explore that reason later, but for now, to illustrate what I'm trying to illustrate. So you see it stopped execution on the first cell, but these others did not run. And assuming this had scrolled all the way down, if this turns empty, then it means that execution stopped before. I want to do something that will generate while true. Print 1 and then kernel restart and run all. So this one, I've generated an infinite loop here. So this is just running indefinitely. To show you also something else, when you restart and run all and you find that there's an asterisk within the brackets, it means that there's a previous cell that is still running. And it continues running, and so long as it's running, it'll always be an asterisk. This changes into a number once the execution has stopped. Running. So if I interrupt this, you see it changes to a number. So that again gives you a clue that there's probably something wrong with your code somewhere. So what you'll do, so let me push this down, and then kernel restart and run all, restart and run all. So you see these first 3 cells have successfully executed and we have an output. When we come to while true, that one is a star. And then down at the bottom, these are also asterisks. So this gives you a clue that maybe something, so you can scroll back up until the point where you see there's an asterisk and then the cell before that has been executed. And that will show you that you have a problem in that cell that you probably need to fix. Or maybe the code in that cell is very heavy and it's taking a while to run. That's why it's taking forever to finish executing. But at least it gives you an idea of what's going on. And then you can stop and try and fix the error. Then there was the issue of print try. Try is a keyword. I shouldn't have used that. Tried. And then so kernel restart run all. So same thing. If you find that you are expecting this code to execute, but then it's turned blank, you can scroll back up and then you'll see that at this point there was an error. then a number was generated for the execution of that cell. It was not a successful execution, but the execution took place. And then you scroll up, you see that your previous cells successfully executed and you got the desired output. So now this also points you to a clue that maybe there's a problem that you need to look at and try and fix. And so now you can go ahead to this specific cell and fix what's going on. Then the last thing I want to touch on before we get now into the actual Python itself are error messages. Error messages are very, very helpful. In the beginning, it's inevitable. You will ask me time and time again that I tried to run this and it gave me an error, what's going on? The beauty about Jupyter Notebook and using Python to develop with Jupyter Notebook, and even Python in general actually, is that being an interpreted language, it goes line by line. Remember, I talked about the difference between interpreted language and a compiled language. An interpreted language like Python, it'll go to the first line, execute that. If it's successful, it goes to the next line, executes that, and on and on and on. And you get the output as it goes along. But when it comes to a line that has an error, then it stops there and it generates an error message. Whereas for a compiled program, it will have to go through all the lines in your program, make sure that there were no errors, and if there are no errors, generates the output software that then now you run. And so the compilation will fail if there's an error. So everything has to be right before the code can run. For Python, everything doesn't have to be right. If prior lines are right, those ones will execute. Then the line at which there's an error, that's going to fail, and the execution will stop at that point, which is good because it's also very clear on the error messages that are generated. And so what happens, you'll find there are different types of errors. This specific one, we've been told it's a name error. And then it's going to point to the line where that error occurred. In this case, it points to that line. And then it gives you what error that is. So name error, name tried is not defined, which means that I'm trying to print something that I have not defined. Again, when you look into variables and everything, I'll explain this some more. But for now, it just shows that tried is not defined and returns that as an error. If I was to do 3 divided by 0, try and run that, 0 division error, division by 0. So it's very clear on what type of errors there are. And this is very good when you're trying to troubleshoot your code. So usually, again, from now on, once we start like on the actual coding itself, if an error comes up, yes, you can reach out to me and say, I have an error. But what will even be very helpful to help you resolve that is that scroll until you come down to this point here, and this will tell you what kind of error that is. Then when you tell me, yes, I got an error, and this is the error that I got, that makes it easier now for me to help you troubleshoot your problem. Then there's also another error, for example, the syntax error. And syntax error basically shows you that there's something about how you've written your code that is not following the rules of Python. That's what syntax error is. In this case, we have seen an expected EOF. EOF stands for end of file while passing. It means that the interpreter went through this line and it realized that there's something that is missing that needs to be there that is not there. And then when you come to the specific error message, let me zoom my screen a bit so you can see a bit clearly. You see there's this little caret, this little up arrow, which points to where that error is happening. In this case, it's showing me that whatever is missing is supposed to be at this point, which gives you a clue that maybe, yes, indeed, I'm missing a closing parenthesis on there. So if I go ahead and add it, I no longer have that error in place. So error messages, very, very good in helping you debug your code. And so I encourage you, even as we move on, anytime you experience an error, the first thing you need to do is, first of all, scroll down and see what that error is. And you're like, yes, I've experienced this error and this is the error message. And that makes it much easier for Fiona or I to help you debug your code. Any questions on this? If none, everything is clear. It's now 10:41. We've completed this introductory phase, taking you through Jupyter Notebook and the interface and everything and the different controls. So I suggest we take a 15-minute break. We shall be back at 10:55. Then now we can start on the Python programming proper. Okay, so 15-minute break, back at 10:55 to now start on Python proper. Or you opened Jupyter Lab, which we can still go ahead and use, but did Jupyter Notebook completely refuse to open up? What you've opened is Jupyter Lab, not Jupyter Notebook. So go back to the Anaconda application.
Yeah.
And then launch Jupyter Notebook, not Jupyter Lab.
Oh, Jupyter Notebook, eh?
Yes, launch Jupyter Notebook.
Okay.
This still works, just that since we're using Notebook, I want us to just be all on the same page. So now click on desktop.
So here?
No, just on the actual link itself.
There.
Yes. Then now new folder. Then untitled folder. Where it appears, click on the checkbox on its left.
Oh, yeah. Okay.
Then rename.
So I right click?
No, just select it. And
Yes.
then now at the top, there's a rename button.
Oh, here.
Yeah, so rename that to data science. Rename, enter, go back in, again, create a new, go into it, click on the name itself. Just click on the name
data
itself.
Science, eh?
Yes. Then new folder and rename that to Python.
Then another folder.
Yes. Then just checkbox, rename to Python. Rename. Then now go into the folder.
So I can double click.
No, just once. Just click once on the name. Yes, then now you can do the new Python notebook.
Here.
So, yes, new Python 3.
Okay.
Then now rename that to Python. The untitled, change from untitled. Click on untitled at the very top.
Where is it?
Untitled to the right of Jupyter.
Oh, here.
Yes. And change that to Python.
Okay.
Then rename. Good. Now we're on the same page.
Oh, thanks.
Sawa. So we've gone through setup and everything, the interface. We can now begin programming proper. And usually the first thing we do in any programming language is printing hello world. And that's as simple as print, parentheses, quotation marks, hello world. Run that, and you have your first computer program. So all of you just go ahead and do that. Print, in parentheses, hello world. Quotation marks can either be single or double. I'll explain that when we get to the specific portion. And then just within the quotation marks, hello world, and go ahead and print that. So now that we've done our first computer program, we can go ahead and look at various things about it. The first thing I'm going to start with actually is going to be comments. So we're going to add a new cell. I'm going to change that to a markdown and call these comments. Oh, the one thing I should have mentioned for markdown cells, remember that I'd mentioned here that there's a heading which you can use, but usually instead of doing that, I just go ahead and create the different headings myself. And you do that in a markdown cell, use the hash mark. So the hash, so one hash will be the biggest level of heading. So that's heading 1. 2 will be heading 2. 3, heading 3. And then the last one, 4, heading 4. Heading 4. So these are the different headings. So I'm going to add comments. So I'll take you through the comments. Let me see, we have done print world comments. I'll take you through the comments. Then Fiona is going now to proceed from there, starting with data types and everything. Emmeline, I've just seen your message. I mean, the only thing that we've done is that we started with the first computer program, which is print hello world. So the print command, and then the parentheses. Then within the parentheses, within quotation marks, the text that you want to print. And I said you can either use a single quotation or double quotation, both are allowed. You have to be consistent. In this case, I've used single, so I've gone ahead. Once you've printed that, once you've typed that out, just run the cell and you get your output, hello world. You can do the same with the double quotation marks instead of the single. So hello world, and you get the same. Then I'd say that we're going to start with the comments, but before that, I wanted to show that you can have different levels of headings in your markdown cells. So there's the heading 1, heading 2, heading 3, heading 4, and that's just by the number of hash marks before the specific heading. This sort of like break up your as you're documenting your code in different sections. So the first one can be the top level heading, and then the second one can be like the next level below that, and on and on. So you use these in the course of documenting your code. Once we have that, then now I came up with this new cell on comments, which I'm just going to briefly, which I'm going to explain, and then Fiona is going to take over and walk you through the actual now programming itself from beginning with data types. Comments help you explain what your code, what your code is doing, either to yourself, to your future self, because you might be doing something now and you might not, once you've launched the software and you need to either maintain it or upgrade it or change it or whatever changes you need to make, and then you come back to it even a month from now, and you might see a section of code, and if you don't add a comment, it'll confuse you. You might not know exactly what's going on. You might not understand why you did things a certain way. And so comments help you help you document what's going on so that in future, you don't have to try and guess what you are doing. You can easily see. You can easily look at it and find out, okay, this is what I was trying to do. Dan, I've just seen your message. Please share your screen so that we can see.
Just 1 minute.
Oh, that's because there has to be a space between the hash mark and the word itself.
Okay.
Yes.
Okay,
Yes.
thanks.
Yeah,
all right.
Welcome. Okay. Yeah, so like I said, comments help you document your code. So let me do x equals 3, y equals 4, x plus 3. And then I can add a comment. And comments are prefaced by a hash mark. So hash, anything to the right of a hash mark is a comment. So x plus 3, I am adding 2 values. And you'll notice that once the hash mark is put in place, the text turns blue and it is in italics. So I go ahead and run that and I get my value 6. Whatever is in the comment is not executed. If I was to do, I am adding 2 values and I ran that, then I will get an error. Invalid syntax, it doesn't know what's going on. But if I change this into a comment by adding a hash mark and I run that, you find that the cell has run successfully, but I don't have an output because a comment is just giving me information. You will notice that unlike a markdown cell, I still get that this is considered a code cell, and it shows by the number that that cell has been executed. Whereas for a markdown cell, I don't have any numbers to the left of them. So these ones, because they're not code cells, you're not going to get numbers, meaning that these are not code cells that were executed. You can also have a comment. It doesn't have to be at the beginning of the line. It can be anywhere before the line. So say I do 3 divided by 4, and then I add my comment after that. I am dividing, actually, let me do with the variables, x divided by 4, y. I am dividing 2 values. Go ahead, and I get back my answer. The comment is not reproduced in the output. So long as you have the hash mark, everything to the left of that is a comment. The other reason you might need a comment is that maybe you want to section off a portion of code that you do not want to execute. So let's say we have x divided by y times x. Let me add a new variable. Z equals 5. So times z. So if I go ahead and if I run that, I get my output. But assuming I want to just do the division bit and ignore the multiplication, so I can go ahead and make everything to the left of the comment of the hash mark into a comment. And if I run that, I get my execution in place, ignoring that whatever is to the right of that. If I have, instead of doing that, I have multiple lines. So x plus 3, and then I want to do, let me assign this to what? Q is equals to x plus 3. And then I want to do y plus q. Then I want to do z divided by q. Actually, let me get this in print statements so that I get the output. So print, and then, so if I go ahead and do that, so I get my values. X, we remember, was 3, so 3 plus 3 is 6. And then Q is 6 plus Y, 6 plus 4 is 10, so we get our output 10. And then we have Z is 5. 5 divided by Q, Q is 6. So 5 divided by 6 is 0.8344. But assuming in doing all this, I don't want to print this first statement. So if I go ahead and I comment that out and I run it, then I only get the third comment printed. I mean, the second comment, the second print statement running. But the first print statement, because it has been commented out, is not going to run. So those are the 2 uses of comments: documenting your code, or removing portions of your code that you do not want to be executed. And you might do that maybe because you're trying to troubleshoot your code, or you're trying to explore something else. And so you comment out a section of it, and you run another section and you see what happens, you make changes, then you bring back the one that you had commented out and make it executable again. And then, as with always, I'm going to show you something that's going to save you time over time, the keyboard shortcut for that. If you want to comment an entire line of code, So you've seen you can go to the beginning of the line and add the hash mark or remove it. But an easy way of doing it is using the control question mark button. So just press control at the same time, the / key or wherever the question mark appears on your keyboard. You don't have to use shift. So control question mark, and that toggles that line from comment to no comment. And you can do that for multiple lines. If I select all 3 lines and then I just do that, you see it toggles all the lines from comment to no comment. So keyboard shortcut, good to know. Over time, like remember I said, practice is what is required. Over time, all these things start becoming second nature to you. And that's it on comments. Any questions on that?
Hi, Eric.
Hi.
I was noticing here when you have using the print function, the output line doesn't display a number as when you're not using the print function in the previous cell.
Print or this print versus, let me take this print up. Which output?
Okay, so when you're using the print function, the output cell that is showing blank, right, where you have the result. But if you're just using the numbers, like where you have the cells where x is equal to 3, y is equal to 4, the output cell 6 has a number.
Ah, okay, I get what you're saying now. You're talking of these, the out here.
Yes.
That's because print, well, for print, you're asking it to display something. You're not asking it to calculate something. That's the difference between the two. So here you see there's an output because there's a certain, you're running a certain expression, and that expression has an output, and that output is what is being referred to by this. But here there's no mathematical expression, so to speak. So whatever your command you're asking it to run is only regurgitating something. It's like just echoing, it's saying, display this for me, not perform this calculation and then show me the results of that calculation. That's why there's a difference between the two.
Got you. Okay.
Oh, okay. Any other question? If not, I'm going to hand you over to Fiona. I'll still be on the call, available to answer any questions, but from now, I'll just let Fiona continue from there.
Thank you.
Okay, so we're going to continue from there. Today we're going to do the very basics, and then from next session is when we're going to pick up from there. So today just try to learn how Jupyter Notebook works. Even if you don't get the keyboard shortcuts, no worries. As Eric has said, it's practice and then it's going to become second nature to you. So for today, we're just making you comfortable, and then from next session is when it's going to be really hands-on. So let me share my screen. Okay, so let me create a new file. So as you have been told, you can change the name of your file from here, and I'm going to call this, this is an intro to Python, so I'll name it that. You can rename your files from here, or you can come to the file tab, and you can rename it from here, but this saves on time and makes things a bit easier. So the very first thing we're going to go through is data types. So we're going to be working with a lot of data, and among the very first things you'd want to know about your data is what kind of data is it that you're working with. Very similarly to what
Fiona, which screen are you sharing? We are seeing visualization catalog.
Oh, sorry. I hope you can now see the blank notebook intro to Python.
Yes, we see it now.
Okay, sorry about that. So as if you have worked with Excel, you probably understand that there is importance to knowing the kind of data types that the data has been stored as. For instance, if you have something concerning prices of products, you will understand that you will have to put that data in the format of numbers as opposed to text, so that you can be able to perform some mathematical operations on it. If you're storing the names of probably customers or what have you, you'd store them as text as opposed to numbers, because you're not trying to perform any mathematical operations on them. So the very first thing we're going to look at is different kinds of data types for Python. And then after that, we're going to build and see what different data types can do. Different libraries work with different data types. So this is just a basic to cover everything, and then we're going to move from there. So the very first thing I'm going to do is I'm going to create a very simple heading here. So just as you have been shown, you can create a heading from here, but it might take some time, because the very first thing that it does is it creates a level 1 heading. So let me just write what I want to write here so that you can see what is going to happen. So this is a heading 1, it's the largest. If you add another hash after the first one, it becomes a bit smaller. This is a heading 2. You add another one, becomes a bit smaller. This is heading 3, and it goes all the way to heading 6, but they just go getting smaller. So that's 4, 5, and 6. So I'm going to leave this at heading 2. So we have data types. And the very first data type we're going to look at is going to be numbers. Very simple, the very basic. So I will have another heading here. So for me, I'm used to using keyboard shortcuts. So if you see any magic happening on the screen that you would like to know how it's happening, just tell me, and I'm going to show you how to do that. So for example, if you want to create a heading, as opposed to being on the cell and then having to come to this drop down, converting it to a heading, which will automatically convert it to a heading 1. And then you have to keep adding hash marks until you get to the font that you'd like. For a keyboard shortcut, you can go ahead and you can have, for instance, if you want a heading 1, you can press your escape key and then the number 1, that will give you heading 1. If you want a heading 2, you can press the escape key and then number 2. If you want a heading 3, escape key and number 3. So I'm going to have escape number 3, and you can see it has already brought for me the 3 hash marks that dictate I want a heading 3 kind of heading. And what I'm going to do here is, first thing we're going to go through is numbers. Yeah. So very first thing we have is numbers. And so I hope Eric had mentioned this. To run a cell, we have this run. However, for keyboard shortcuts, we use Shift and Enter. So for instance, if I'm here and I want to run this cell, it's just Shift, Enter, and it's going to run. However, if you're not used to that yet, there's the button Run. You click on it and it's going to run. So the very first thing we're going to look at is numbers. And within numbers, there's also a division within numbers. For example, just thinking of it in a real world scenario, you may have whole numbers. These are whole numbers representing maybe number of people, number of units. These are numbers that cannot afford to have a decimal place because they represent whole things. For instance, population, you cannot expect to have a 33.4 million population. That doesn't make any sense. So within numbers, we have what is going to represent whole numbers, numbers of people, number of units, etc., etc. We're also going to have something else that is going to assist us to work with now the decimal places or the kind of fractions that we have. For instance, the price of a product can be 100 shillings and 99 cents. So it can afford to have that decimal point, or you're dividing, maybe you want to get the average area of somewhere. So you have the population and the density. So when you divide the two, you probably will get a number that has a decimal point. So again, that's a different kind of number within Python. So we're going to look at that. Any other kind of numbers? No. So we can look at those first, and then we can see some few operations. So we're going to start with the very basics, which is integer numbers. So integer numbers is, so now this is where a markdown cell comes in. So for a markdown, you can either come to, make sure you're within the cell that you want to convert to a markdown cell. You can come to this drop down, convert it to a markdown. and you can see it is not expecting any input, and that tells you that this is not a code cell, because if we convert it back to a code cell, you see it's telling you that it's expecting some input and then it will give you some output. But for a markdown cell, this is just to allow you to write some notes and what have you within your notebook. So it does not expect any input and thus will not give you any output as well. So you can convert your cell to a markdown. However, for a keyboard shortcut, you can have escape. You can press escape and M and it should be able to bring that for you. So that's what I'll do. Again, keyboard shortcuts, they'll come to you with time. Don't worry much about them. For now, feel very free to use what is here. So no worries about that. So the first thing we're going to have is integers. And this is the data type that is used to store whole numbers. And to run it, so this is a markdown cell. It doesn't expect any input, and that way we do not expect any output from it. So when I run this cell, it's just going to have whatever I've typed in it exactly as it is. So if I click on run, you can see there's no output I expect from that cell because I didn't give it any input as well. It's just going to display the text exactly as I had written it. So integers, these are the data type that is going to store whole numbers. And whole numbers also, as you're going to be typing them, the idea is that they do not have any kind of decimal places. For instance, we have the number 1, which is just an integer. And for you to look at the kind of data type of the data that you have, is it a function or an attribute? I think it should be, it's an attribute. It's a Python attribute, and it's able to tell you the data type of what you're working with. For instance, and the attribute is type, and you're going to see that it's going to turn green. If you see anything in Python within your notebook turning the color green, that means that it's something that is specific to Python. Python has already been programmed for that thing that has turned in green to mean something very specific to Python. So if something appears in green, as we move, you're going to understand why. But if anything turns to green while you're typing, that means that it's something that is specifically for Python. It means that it has been programmed to do something very specific. So it will not be advisable for you to mess around with it as such, because you're most likely to run into some errors. But for this one, this method is able to tell you the data type of the kind of data that you're working with. For example, we can have the data type of just the number 1, and you can see that it tells us that it's an integer. So int is short form for integer, and 1 without any decimal place is an integer. So 1 will be representing maybe 1 person, 1 unit, or what have you. It's a whole number that cannot afford to have a decimal place. So there's the other kind of numbers that we have. If it's not an integer, then it has to be something that rather accepts the use of decimal places. And for that, we call that data type float. So I'm going to go ahead and create another markdown. I have used escape M, but for you, just make sure you're within the cell, come to this drop down and convert your cell to a markdown. Again, as you can see, so for here, if it's a code cell, that means that it expects some certain input, and then you expect some output from the input that you have given it. And that's why you have your input and your output. However, if it's a markdown, you're just trying to make notes within your notebook. So you're not giving it any output, and you should not be expecting any output as well. So the other data type that can be used for Python that allows storing of numbers that have decimal places is called float. I'm going to type out the rest of it before I send this notebook to you guys. So for now, I'll just leave it at that. So float is any number that can afford to have a decimal place. For instance, I can have just 12.5. It won't show you much, but we can now look at the type for this number that we have put on here. And you can see that it tells us that this number is now of the type float because it has a decimal place. So those are the kind of numbers that we have for Python. We have integers and floats. And now something to keep in mind, if you're trying to perform a mathematical operation, you can only perform a mathematical operation on data types that are similar. For instance, if you want to perform an addition operation, you cannot perform an addition operation between an integer and a float. So you may have some data that you're not the one who has created, and then there's some addition that's happening, and then it's going to throw you an error. It's going to be probably a data type error. It's going to tell you that the data types are not compatible. So for you to look at those data types that the types of those of that data that you're trying to do to perform the operation on, this is what you'd use, type, and then you have your data passed within those round brackets. With time, this will become a bit more easier. So don't worry, we are going to go through the type and the round brackets a bit later. This is just to show you what we're after. So as I've said, if you're trying to perform operations, you have to make sure if it's a mathematical operation, it has to be an integer and an integer. And if it's a float, it's a float and a float. If you try to perform it with an integer and a float, it's going to throw an error. And so we're going to look at that just right now. So right now we're going to start looking at mathematical operations, and I am going to have a heading 3 here. So let me just call them operations. And the first one that we're going to go through is going to be addition. So addition is just the very basic addition. I'm going to show you how to do it here. If you understand what's happening here, as we move to NumPy and Pandas, you're going to be able to understand what is going to be happening, because it's going to be happening on a much larger scale. But for now, we're just going to use very simple numbers, very simple examples, just for you to get the basics. So for example, we can have an addition of 1 plus 1. 1 plus 1, and you can see that it gives us the output. And you can see that I have 1 as an integer and 1 as an integer, and the output has been given as an integer to me too, but we can check that. So we have, you can see that when you add 2 integers together, the output that you're going to get is also going to be an integer. We can do the same thing with the float. So for instance, we can have 12.5. Plus 12.5, and you can see that the output that it gives us is also a float, in as much as it's a 0.0, just that the numbers that we gave in our output were in the format of a float. Then the output we expect is also going to be in the format of a float, even if it is a 0.0. So we can check the type for this. So 12.5, sorry, plus 12.5. And you can see that it tells us our output is float, because the input that we gave it was also in type of float. So we can now try see if we can perform an operation between a float and an integer. For instance, we can have 1 plus 1, which is an integer, and then we can have 12.5, which is a float. And okay, so at this point, it's not going to give you an error. The error is going to come in as we move on to NumPy. Sorry about that. So at this point, it's not going to give you any errors. However, now for you, you can now start noting a few 1, 2, 3 things. So we have given in one of our numbers as an integer, and then the other number is a float. However, our output, we can see it's a 0.5. That means that our output is in the float kind of format. So this may be desirable if you're not particularly keen on the kind of format that your data is in. However, sometimes you may be very keen in that you want integer inputs only and integer outputs only. So at this point, this is something that is called is it downcasting? If I'm not wrong, it should be, I think it's down. Is it up? It's either upcasting or downcasting. I'm going to confirm that. And the idea is that Python during runtime is now going to convert if it's an integer parameter that you have given during runtime, it's going to convert it to a float. So that happens implicitly. However, you may find that desirable if you're not so much interested in the format of the data, However, for someone who's very, very keen on that, you do not want that conversion from integer to float because maybe you're trying to preserve the data that you have and what have you, then that is going to, then you can see that at this point, it becomes very tricky to add integers and floats together. This kind of operation is not, if you're not keen, it might end up changing some of your data, which is not desirable. So as much as at this point, it's not throwing an error, it's not advisable to perform operations on different kinds of data types because there is something that is going to happen in the background that you might not be able to see it, but it might affect the integrity of your data. So that is a very first thing. That was very simple, just addition. Think we can go on to, feel free to stop me at any time, but I'm just going to make this a smooth kind of flow, but feel free to stop me at any time. So after this, we can look at another operation, very simple. We can look at subtraction. So for subtraction, we can have, for instance, 10 minus 7. So the subtraction sign should be what you usually use as a hyphen, but at this point, it's going to be interpreted as a subtraction sign. So 10 minus 7, we get our output of 3. We can also try it with our float numbers just to see what happens. These are just very random numbers. 19.6, we can subtract, say, 8.7. And you can see the output that it gives you. Again, the kind of input that you give it is going to affect the kind of output that you're going to have. If you give integers, expect integers. If you give floats, expect to be given back floats. And if you perform the operation between an integer and a float, for instance, we can have, say, 10 minus, say, 7.6. Expect your output to be a float because in the background, some few 1, 2, 3 things have happened, and 10 has most likely been converted to a float before this has happened, so that this happens, so that this operation happens correctly. When we get to NumPy, you might be able to see this a bit better. But again, at this point, this will not throw an error, and it's fine. You're going to get what you're after. However, in the background, something not very desirable to you has happened. So again, you're going to get the output that you're after, but performing operations between different kinds of data formats is not particularly advisable. So keep that in mind. Then after that, we can look at something else. We can look at multiplication. So multiplication, this is something very simple. However, for Python, the sign, or rather the character that denotes that you're trying to multiply something by something, is the asterisk. So for instance, we can have 10, and then maybe I want to multiply it by 10 again. So I'm going to have 10, and then I'm going to have my asterisk, and then I'm going to have the number that I want to multiply my first number. So I have my 10 by 10 is 100. So at this point, you can now start having comments within your cell so that maybe you have something. For instance, multiplication, you might not remember that the asterisk is what represents the multiplication sign. So you can have your comment there, just have your hash, and then everything that comes to the right of the hash is going to be treated as a comment. And even as no matter how many times you run this cell, whatever is to the right of the comment is never going to show up in your output. So here, for example, we can have asterisk represents multiplication. Multiplication sign. So even as I run this again, you can see I just get the output of 10 by 10. I do not see the asterisk. The asterisk represents the multiplication sign, because at this point, this is now a comment because it's to the right of our hash character. So we can also try do the same for Okay. So let me just go through something. Then we can have for floats, for instance, we can have 10.5, multiply that with say 5. Sorry, let me make this another float. You can see float multiplied by float will give you a float. Also, you can also opt to do your integer and your float operation. For instance, you can have 10 by say 7.5, and you can expect the output to be a float because one of the inputs you gave was a float, and that's going to change. That's going to determine a few things that are happening in the background, and that means that your output is also going to be in the float kind of format. So just one last thing before I give it back to Eric. So at this point, we can have division. So for division, there are a couple of things that you have to take note of. So for this, Eric, you can just take over for this, and then you can explain everything that happens under division. The float division, division by zero, modulus can also fall under here so that you can cover everything together.
Yeah, go ahead and do that. So actually, before we do division, there's one more thing under multiplication that I'm going to show you. Let me share my screen. But you can go ahead and just continue on the same notebook that you're doing. Mine is just going to be like addendum to what Fiona has been sharing. Give me a second. Let me do Python. Oh, I need to restart. Sorry, give me a second. Okay, everyone sees my screen?
Yeah.
Okay, good. Yeah, so for multiplication, Fiona has taken you through the just multiplying straight numbers, but sometimes you might want to have powers, and for powers, you'd use the double asterisks. So say you want to do 2 to power 3, it's just 2 double asterisks, and that returns the value 8. So if it's a single, it's just regular straight multiplication. But if it's a double asterisk, then you're raising the number to the power of the other number. In this case, we're raising 2 to the power 3, multiplying 2 times 2 times 2, and that gives us now the value 8. If you want to raise numbers to powers, that's what happens. Then for division, there is there's true division, and true division is just the traditional one, a number divided by another. So 10, sorry. Change this to code. So 10 divided by 5. When you divide for true division, it will always return a float value, even if you're dividing integers.
Eric, please mention that for the division, it's a /. They might be looking for the whatever it is.
Yes. So the division is the /, which in most keyboards is the one that's coupled to the question mark. So /. And for true division, like I've said, it always returns float or float numbers, even if you're using integers. For the other operations, so addition, if I add 2 integers, I get back an integer. If I subtract an integer from another, I get back an integer. And then if I multiply 2 integers, I get back an integer. But for division, you will always get back floats. Just the way Python has been set up. That there are other, remember I'd mentioned about the Python being a dynamically typed language. This is, this is one of the consequences of it being a dynamically typed language. When you divide, then the result that comes out is that an integer, is that a float, what is it supposed to be? And so automatically it just assigns it to float. For a statically typed language like C, once you have defined that a variable is an integer, then you can only perform integer operations with it. If you've defined it as a float, you can only perform float operations with it. You cannot define an integer and then try and do a float operation with it. But for Python, because of its dynamically typed nature, it allows you to do this. And so I can even divide a float by an integer and get back a float. So integer by integer, you'll always get back floats. That's for true division. You also have floor division. And what this does is that it enables you to divide an integer by another, or even a float by another, and return a whole number. So what floor division does is that if you say, for example, I'm dividing that 10 divided by 5, instead of using a single slash, I use double slash, which indicates that I'm doing floor division instead of integer division. So 10 divided by 5 now returns an integer. And you'll notice that in cell 10, it returns it as 2.0, which is a float value. But in cell 11, it returns it just as 2, which is an integer. And what floor division does, it returns the nearest whole number that results when you divide a number by another. So let me use divided by 3. So if I do 12 divided by 3, true division, I get back 4.0. But if I do 12 floor division by 3, I get back 4. If I increase, so for as long as the numbers are between the number that's going to return a result without a remainder, up until the next one, it's always going to return that nearest whole number. So if I do 13 floor division by 3, it'll return 4. If I do 14, it'll return 4. And only when I get to 15, will it return the next value up. And similarly, if I go to below 12 and do 11, it's going to return 3, because the nearest whole number that goes into 11 when you divide by 3 is 3. Then even if I now do the same thing with a floating number, and then I divide that by an integer, it's going to return a float as the value, because I'm doing a float divided by an integer, but then it's going to return the nearest whole number that divisor can go into, the number that is dividing it. If I was to change this to 10 divided by 2, you see I get back the float division, you see I get back the whole number 5. But if it's an integer, then it's going to return the nearest whole number as a float. So that's the difference between true division and floor division. And sometimes you might wonder, why do you need one over the other? So, well, true division is, for a majority of the cases, is where you'll use true division, where you really don't mind whether the number returned is an integer or a float. But for floor division, maybe you're working on an operation where you need to know just whole numbers. You're not interested in fractional numbers. Or if you're doing, you're counting something and you're counting a population, and maybe you want to know number of the population density or something like that, and you're only interested in whole number densities, not in densities that have fractional parts to it. That's where a use case for floor division will come in. Then the last thing in division that I'm going to share is going to be the modulus function. So whereas the floor division returns the nearest whole number, modulus returns the remainder of an operation. Say you want to determine, you have certain items and you want to divide between a certain number of people, and you want to know how much is left behind. Modulus is the one that helps you do that. but the most practical use case for modulus is usually in testing the divisibility of numbers. If you want to know whether a number is divisible by another, if it returns a certain remainder, then it means that that number is not divisible by the other one. But if it doesn't return any remainder, then it means it is indeed divisible. Modulus, the operator sign for the modulus is the percent sign, which is the one that is above the 5 on the keyboard. So shift 5 to get the percent sign. So if I want to do, say, 10 modulus 2, this is going to return 0 because 10 divided by 2 does not have any remainder. But if I do 10 modulus 3, then I'm going to get a remainder 1 because 3 is not divisible by 10. If I switch this around to, say, 6, I get back 4 as my remainder. So that's what modulus does. If you're testing for a divisibility, like say you want to run an operation that tests whether a number is even or not, all you need to do is test whether there's a remainder when you divide that number by 2. So 10 divided by 2 returns 0, which means that 10 is an even number. But 13 divided by 2 returns 1, which means, or rather 13 modulus 2 returns 1, which means that 13 is not an even number. So that's how you do modulus and the use case for modulus. Any questions on those division and power and modulus function operations?
Yeah, just maybe a question here for the powers. You use the double asterisk, so that becomes like the power of 2.
Yes.
How about if you want to go higher to get higher powers?
Higher powers how?
Like if let's say I put 2 with the 3 asterisks, that give us a number, right? It wouldn't like go to like 2 to the power of 4, 2 to the power of 8, something like that. How do we get to do that part? I'm not so sure.
So
like if 2 to power 3 gives you 8, but how about if you want to go to 2 to power 8?
Well, for now we're using specific numbers. You just change the number itself. Yeah, you just change the number itself, 2 to the power 34. Yeah, so it's x to x. Let me use variables x to the actually comment. Very good, whatever. So it is what I'm going to do. X equals 2, y equals 23. So, and then I'll do x, y. So it is x to the power y.
Okay.
That's what it is now. Yes.
All right, got you. All right.
Okay.
For the space,
any other question?
Is there any?
Pardon?
I see that when you're writing your code, you put spacing between every like 10 space divided by 5. Is the space mean or is just for?
The space is not needed. The thing about Python is that space is not an issue other than indentation. And when we come to the situation where indentation comes into play, we shall explain that. But besides indentation, space is not an issue. I do space for readability. If I did that, it will still work. If I did that, and if I did that, it will still work. If I did that number of spaces there and no space there, it will still work. So in Python, space is not an issue. For me, I do it this way because this is how I've gotten used to writing my code. So it's a question of you develop a system for you that works. I find that when I write my code this way, I find it more readable, and that's why I do it.
Yeah, it promotes readability of code.
Exactly. That's why I add the spaces in my code. But yeah, it doesn't matter.
All right.
Okay, any other question? If not, I hand back to Fiona.
So I can see time has moved and you've actually taken in quite a lot already today. So I'm just going to explain variables because you've seen Eric doing some x equals to y equals to, just so that you can understand a few of the things that have been happening today, then I think we can call it a day. Yeah, So here we're going to have, so we'll start with variables. So you have seen Eric doing some x equals to 2, y equals to 3, or what have you. So x and y are called variables. Variables are memory locations. There are, in terms of, okay, so a variable is going to point to a memory location. You're going to have data, you've stored it somewhere. However, for example, in the event you have, maybe you were out collecting some few products or product prices. So you probably have a long list of product names that you have collected from somewhere. So you're not in a position to remember all of those names, either individually or as the entire list that you have. So it will be better for you to be able to store all that information somewhere, and then when you need it, you can be able to access it. And that is what variables do for you. So variables they are memory locations. Variables are actually memory locations. So it's for you to give, so you have some data, you store it somewhere, and then for you to be able to access that data, you're going to give it a name that you're going to be knowing about, that is going to be pointing towards that memory location that is going to be storing your data. So a variable is going to be that name that you have given that memory location that is storing the data that is important to you. So for example, I'll just use the very simple example that we have been shown using the powers. So for instance, we can have, so x equals to, we had say x is equals to 2. So what is happening here, this is called assignment. So because Python is a dynamically typed language, we do not have to do declaration and then assignment. If it was a language such as C, something that is statically typed, it means that you have to declare your variables first and then you can assign your variables. However, because Python is dynamically typed, then you do not need to do the declaration. You can just go ahead and go to the assignment. So at this point, we have the equal sign. I want you to think of this as an English statement. X is equals to 2. So what you're saying is that the value of X is now 2. X is equals to 2. If you think of it as a very simple English statement without thinking that it's code you're writing, it's something very simple. You're now giving the value of X. Now the current now value of X is going to be 2. You have assigned 2 to the variable X. So that is what is happening here. Anything that is to the right of the equal sign is what you are assigning to what is to the left of the equal sign. So what is happening here is that we have our data 2. So this is just a very arbitrary data. This could be the number 2. It could be that long list of products that you have gotten from somewhere, or product prices, or what have you, that you're not in a position to remember each and every one of them individually. You can put all of them together and then you can assign them to a variable X. And then now anytime you're going to need that data, you can just call the variable X, and then you're going to have that data, as opposed to having to remember the data individually. So the very first thing that you have to do is assign. You have to now give that data the name that you want to be used to point to that memory location, and that is your variable. So the very first thing you have to do is assign the data to a variable. Let me have that here. So assigning data to a variable. And at this point, assignment is a background operation. You will not be able to see any output. Whatever has happened, that assigning 2 to the variable X happens in the background. So for you to be able to see the output of this assignment that you have done, it means calling your variable. And calling your variable is very simple. So for us, we have our variable X. So calling the variable X is just typing that X, either within the same cell or in a different cell. Okay, so you can assign more values. We're going to look at that a bit later, because that is now going to be getting into a different kind of data type. So we can have a different kind of data type, for instance, a list. just do that here. So a list, we're going to understand a bit later what that does, but a list is now going to enable you to work with a collection of items. So a list is represented by square brackets around it. So we can have, say, 2, 3, 4, 5, yeah. So we can have that. So when they're within these square brackets, they're now going to be treated as one collection. They're going to be treated they're going to be treated as one unit. So what we have done now at this point is we're going to have been assigning all these values to this variable X. And so now for us to be able to access this variables, the data that has been stored by the variable, we just need to call the variable, and you can do that either in the same cell that you have done the assignment, or you can do it in a different cell. But let me show you in a different cell first. So as I've said, the assignment, this happens, it's a background operation. You will not be able to see any output from it. However, something has happened. And what has happened is that this data has now been stored in a memory location, and that memory location, you have given it the name X. So anytime you're going to be calling this variable X, it's going to now be showing you the data that has been stored within that memory location. So as I've said, calling the variable is just typing the variable either in the same cell that you have done your assignment, or in a different cell. So if I do it in a different cell, I just type X, and then I run it, and it's now going to be able to show me the data that has been held within that memory location. So as we move to working with larger kinds of data and what have you, this is going to be very important. And variables generally, they promote the reusability of your code, because maybe even any time that you would have needed to access this data, you'd have to type 2, 3, 4, 5, and this is just arbitrary data. If you have a lot of data, it's going to be time consuming and what have you. So you can just store your data within a variable, and then you can call that variable as many times as you'd want. However, something to keep in mind is that I've called this variable X. If I want to store some other data and I store it within a variable also called X, then it's going to override what was already there. For example, I can have, say, X equals to, can now have a list of product names. So we're going to look at strings, and strings is now the data type that allows you to store text characters and what have you. So strings are represented by single quotes or double quotes around them. Don't worry much, we're going to see this later in our next session. But for now, I can just have a list of the people who are in class. So I can see, I can see Jacqueline. So we have Jacqueline, we have Kelvin. Who else is here with us? And okay, I can't see anyone else. So I'm going to have myself, and I can have Eric. Okay. So at this point, this is going to be an assignment. I'm going to be assigning this list of names to this variable X, because I may not be in a position to remember all these names either individually or just as a list. I may not be in a position to remember all of them as I'll be typing my code. So I can assign them to a variable, and then anytime I need to access that data, I just need to call the variable. So I can do this, and then I can call the variable, but this time I'll call it in the same cell just so you can see the output. So you can see at this point, now we have done our assignment, we've done our assignment, and we've called our variable. So even if I was to call this variable X in a different cell, you can now see that X is now referring to the most recent data that we give that variable. So be very careful as you're naming your data. If you have too many X's, X is only going to show you the most recent assignment that you gave it. So any assignment that you gave it prior to that is going to be overridden. So be sure to give, as a rule of thumb, it's usually good to give your data variable names that give you a hint of what your data is about. For instance, instead of calling this list of students X, I would have called it exactly that. I would have called it students, we can say So also how I'm naming my variables, we're going to see this in our next session. So don't worry much about this. So we can have students cohort 14, and then I can just copy this. And then I can call it. So another thing, sorry, that has become a bit too long for me to type. So another thing that Jupyter Notebook is going to be able to do for you that's really amazing is that it can be able to auto-complete for you. So for example, you can see as you start working with a lot of data and you have to put all of them in variables, and these variables might be some longer words such that it's able to clearly tell you what kind of data it's holding. For instance, students cohort 14 becomes a bit too tedious to type. As you keep typing, it might become a bit too tricky to type the whole thing. So Jupyter Notebook goes ahead and can be able to provide autocomplete for you. And the idea of autocomplete is any variables that you have declared within this notebook, that is just only within this notebook, then you can start typing some few characters and then you can hit the tab key and then it's going to give you some autocomplete options. So for instance, I can start typing students. I hit my tab key and you can see that it has auto-completed for me the variable that has started with those few characters, but only within this notebook. So I can go ahead and now run this cell, and you can see that it's now telling me that this list of students has now been stored within the variable students cohort 14. So anytime within this notebook, it might have a lot of code, but anytime I need to remember the students who are within cohort 14, as opposed to remembering the individual names, I can just call the variable students 14 for, students cohort 14, and I call it, and I'm going to be able to see the data that has been held within that variable. So there is still a lot on variables that we have to cover, but because of time, I'm going to let you go, because if we start that, we might finish in about an hour or so, and I don't want to keep you here for that long. So I hope so far there is anything concerning Jupyter Notebook that you can see here that is not making any sense to you. Feel free to reach out, or you can ask before we end this session. Any questions on what we have covered so far, you can go ahead and ask, but I think for today, this is all I will give you. Okay, so
any questions from anyone on anything we've done today? Okay, if not, I see Musella at the bottom. I had asked people to introduce themselves and just say who they are, what they do, what their background is, and the expectations. And that's because I was not at the orientation on Tuesday. So that's for me just to get to know you. So you can just introduce yourself.
Like now.
Yeah, just a brief introduction, yeah, before we end.
Okay, I think then I'll just start with myself. So again, I'm Murugi Kamau. I have my background in informatics and computer science. I also started just as with Eric, I started as a student at Predictive Analytics, and here I am now. So I hope that goes to tell you that it's pretty doable. Whatever we're doing, it's very, very, very doable. So don't worry. What we're doing right now as an introduction to Python this is not a coding class, so don't worry. But we have to go through this introduction to Python because the libraries that are used for data science, that is NumPy, Pandas, they're built in Python. So for you to be able to understand some few things that are going to be happening later, you need to understand this very, very basics. So don't worry, this is not a coding class. Things will get easier with time, don't worry. And yeah, it's doable. It's been great to meet you guys. Hopefully this is going to be an amazing journey.
Thanks. No, sorry, you misunderstood me. It was just Musella. The rest had introduced themselves, but that's good anyway. So yeah, we'll just have Musella introduce and then we can end the session.
Hello?
Hello.
Yeah, are you getting me?
Yes, yes.
Yeah, my name is Safan Msela. I studied statistics and mathematics in college. That was quite a long time. But currently I'm engaged with a financial institution. And Akela, I'm really interested in understanding data science because it's the current gold mine. It looks tricky, but I believe with the time, I'll get to understand it. Thank you.
Asante sana, thank you very much. So that's it for this first session. We are going to share a link to the recording so that you can access it later in the course of the week. And then also, well, we've done very little in terms of the notebook, but we can share just the notebook with a bit that has been covered today. Actually, what I'll do, I'll share the notebook for this for all of Python, and you can even read ahead and prepare. And even as you go through the material, if any questions come up, at least you can be a bit prepared for that. So this should be with you latest mid-morning Monday, if possible sooner than that. But for now, we want to say thank you. There's nothing else. We can go ahead and end the meeting. So we'll just wish you all a wonderful weekend.
All right, guys. So have a great weekend and have an awesome week next week. See you next week.